Hi everybody, when we left off the other day we were talking about annuities due. I'm going to pick it up on page 34 in our text. We're dealing with non-annual compounding. Now as you know, if you have a car loan or mortgage payment, that compounding or discounting is not done annually, it's done monthly, and that means that we can use our tables for increments in other than 1 year, and that's very important to us because when you have a mortgage, for example, you have to make payments that are in less than 1 year. They are due monthly. Same with the car payment, okay? So the tables do not refer to time periods as years, as I note up here on my schedule, but they are periods. Those periods can be for anything other than a year. I've not complicated that up until now, but now because we have to deal with practical applications, we have to say, what if those periods are not 1 year, but they are half years, quarters, or months, or anything around that. Okay, so I've put together an Excel spreadsheet here, as you can see. Let's take your Visa statement or your MasterCard statement. It tells you that interest on your unpaid balance is 1.5% per month. Don't believe me, go look it up. Okay, so you might think to yourself, well that's 12 times 1.5, that's 18%. That's not true. Okay, because they are doing the compounding calculation monthly. Ladies and gentlemen, that means it's not 12 times 1.5%. It is not 18%. You might have heard of the effective annual rate. That's what I'm going to explain to you before we get into our next topic here in Chapter 2. So for illustrative purposes, let's assume in January you're going to go out and use your Visa or MasterCard and spend $1,000 and not pay the bill. Okay, which is a terrible thing to do, as I'll demonstrate to you. So they're going to say, well, that's 15 bucks. 1.5% of $1,000 means that you owe us $1,000 and 15% another, 1.5%, $15 more. So at the end of January, you actually owe the Visa company $1,015. Now you're not going to pay it. You're not going to use the card anymore, but you're not going to pay the balance. Okay. So in February, there's the magic of compounding again, ladies and gentlemen. 1,015 times 1.5, not the original 1,000. No, now they're compounding. So Visa is going to charge you more. So at the end of February, now you owe $1,030.23. Now let's go back to our original numbers, our original formulas. Using 1 plus I to the nth power, and I'm going to apply that to $1,000. And Visa has said, the interest rate is 1.5% per month. Now, in my class, we always use annual interest rates, but this is right off your Visa bill, so we're assuming it's 1.5% per month. So we take that to the 12th power, 12 periods, 12 months, right? So, at the end of December, if you have not paid this bill and you just let Visa keep accruing interest, you now owe them $1,195.62. What percent is that? Well, take the $195.62 divided by the original $1,000 you owe them, and that means you don't owe them 18%, you owe them 19.56%, okay? The more often you compound, the more interest accumulates. This is how bankers, lenders make their money. This is something that as an investor or a borrower that you need to be keenly aware of, okay? This is the effective annual interest rate. Now, under some of the laws that we have in this country, lenders are required to disclose this to you. However, sometimes the manner in which they do so can be a little subtle. So you want to make sure you ask these questions. Please remember, as I often tell my classes, my wife and I once went to borrow money on a car loan from a well-known car dealer in this area. They told us it was between 1 and 2%. I did the math and it came out to much higher. So you want to make sure you can do this math to protect your own money. Okay? So as I indicate here, the more often that interest is compounded, the greater the amount of total interest each year. I'm going to give you some demos later on that you can keep to remember how much early months of interest can be. Okay, remember, interest is not something that's benefiting you. It's a cost of financing. It's a cost of credit. It's something that you are paying to somebody else. Lenders pack the interest into the early months, early periods to a high degree. You want to make sure you're aware of that, okay? Okay, so let's move on. So now let's look at this question here, friends. How do you use our tables for periods that are other than 1 year? You do it the same way as we've done for 1 year, but all you have to do is change how you look at the columns and the rows. All right. So for our example, let's say, highlighted in green here, we're dealing with $80,000, 12%, 3 years. Now, I'm not sure if I'll get it into this lecture or the next one, but I'm going to show you a couple of secrets on which table to use. For now, we're going to say, what will this money grow to? All right, right away, that means we're moving forward on the timeline. $80,000, what will it grow to? It's going to grow at 12%. It's going to grow for 3 years. It's one time only. We move forward in time. That means, based on the secrets I'll tell you in another lecture, that we know we have to use table number 1. Okay, so now if you're following in the book, this is all on page 35. Please make sure you're following along in the text. Okay, so that means if we're going to use these tables for something less than annual, we're going to have to adjust them ever so slightly. The same tables will be used. So we will deal with the 3 most common adjustments to these tables. Semi-annual, twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Okay? Very good. But we are going to be dealing in green with $80,000, 12%, 3 years. Okay. So now what I'd like to start by doing is saying annually, what would that be? Well, annual is very, very easy, ladies and gentlemen. We know if we go to our table for future value of one amount, 12% for, what did I say, 3 years? Yes, 12%, 3 years will be 1.4049. Okay, so if I take 1.4049 and multiply that times, how much am I dealing with? I think it was $80,000. Let me verify that, please, for one moment. Yes, $80,000. Okay, doing it the way that we've done it so far will give us $112,392.40. Okay, that's going to be our baseline. Now that is how we've done everything so far. Now what we have to do is we have to look at other payment periods like this. Okay? So hold on one moment, please. Hi folks, apologies for the interruption. Okay, so now that's 1 year. That's what we're used to. Now let's say that we're going to do it not once, but we're going to compound twice a year. Okay, now let's come over here to my slides. Okay, so whenever you are a lender, you're going to make time a big advantage, okay? And the more you can compound as a lender, the better you do, the more profit you're making. And I'll demonstrate that to you in another lecture. So here's the secret. Okay, the master rule is this. You are going to take our 2 factors, the interest rate and the time. You're going to divide the interest rate by the number of periods that happen in a year, okay? And you're going to take the number of periods that happen in a year times how often they happen. What does that mean in plain English? Okay, there are 2 semi-annual periods in a year, half-year increments, okay? So you're going to take the annual interest amount and divide by 2. You're going to take the number of periods and multiply by 2. What if it's a quarter? You're going to say, okay, I'm going to take the annual interest rate and divide by 4. I'm going to take the number of periods and multiply by 4. So you always take the interest rate and divide, take the periods and multiply. Always by the same number. That number being how many of those periods happen in 1 year. So if the compounding period is semi-annual, there are 2 of them in 1 year. You divide the interest rate by 2 and multiply the periods by 2. It's that easy. It's that easy. Save this. Quarters. Divide the interest rate by 4, multiply the number of periods by 4. So if it's 2 years, you divide the interest rate by 2, and if it's 2 years, you're going to multiply it by 4, and that's 8 periods. Okay? Monthly, what if it's monthly? You divide the interest rate by 12, and this is important because this is probably the most common. A monthly car payment, a monthly loan payment for your house, okay? You multiply the number of periods by 12. Let's demonstrate that going back to our Excel chart. Okay, now we are dealing with 12% 3 years. 12% 3 years, remember that, please. Okay, so 12%. Semi-annual. You divide 12% by 2 and you're going to get 6%, okay? You take 2 times, how many years are we dealing with? 3 years, that's going to be 6 periods. It's that easy. Okay, so let's come out and math it out and see what we get. I go back to table number 1. I'm not going to use 12% anymore. I'm going to come to the 6% column, and I'm going to go down to, there we are, 1.4185, 6% for 6 periods, okay? 3 years times 2 is 6, and half of 12% is 6. The number is 1.4185. Multiplied by $80,000. Let's come on out here and do that. 1.4185 times $80,000, and I get 113. Hey, look, it's bigger than I got before, isn't it? Yeah, of course it is, because I'm compounding more often. Interest is working on interest more often. Let's do it for the other periods as well. Okay, quarterly. If I'm dealing with 12% for 3 years, all right, I'm going to take the interest rate and divide by 4. That's going to give me 3%. And 3 years times 4 quarters per year is going to be 12 periods. Okay, so the factor I'm going to be dealing with will be 3% for 12 periods rather, will be 1.4258. Multiplied by $80,000. All right. It's going to get bigger every time we do this because, again, we're compounding more often. Monthly, 12%, 3 years. If you do it monthly, that's going to be 1%, 12% divided by 12. And that's going to be 3 years times 12 months. That's going to be 36 periods. Okay. Oh boy. Look at the problem. We don't have 36 periods. Well, if you're looking at my book, you have a problem because at the back of the book, the appendix does not have 36, but my Excel spreadsheet allows you to change the numbers. So come over here to 35 and change it to 36 and watch what happens to my numbers. See how they change. That's why the Excel spreadsheet is so much better than using the book, the printed table. Let's take that number, 1.4308. Of course, it's going to be larger. Multiply it by $80,000. And let's math it out. 1.4308 times $80,000. Of course, we knew it was going to be bigger. Okay, so every time we compound, the total number gets bigger and bigger. This is why it's wonderful to be aware of this and be an investor and compound more often. It's also why it's great to be a lender and be able to make money by lending your money and compound over and over and over again. When we come back, I'm going to show you something that's going to shock you about how that can work against you. Okay? So, there's all the data up through slide 44. All my examples are on page 35 and 36. You should be reading up to that point. And when I come back, I'm going to give you a couple of secrets about which table to use, and then I'm going to try to give you the wrap-up lecture aspects for Chapter 2 and start getting into Chapter 3. That is all for now, and I wish you a good afternoon. Stand by, more to come. Bye-bye.